Hello, Chem 1A. This is Chapter 10, Lecture Video 4, and we're going to be talking about bond order, bond length, and energy, and how these three things relate to each other. We'll also talk about fractional bond order, which occurs with resonance structures, and the trend for electronegativity. So what is bond order? Bond order is defined as the number of bonding pairs shared by two atoms in a molecule. Now, this really is just a fancy way of numerically classifying what numbers of bonds you have, right? So if you have a single bond, your bond order then would be 1 because you're sharing one pair of electrons. If you have a double bond, your bond order would be 2 because you're sharing 2 pairs of electrons. And if you have a triple bond, your bond order would be 3 because, again, you're sharing 3 pairs of electrons. Now, most of the time, our bond orders end up being 1, 2, or 3, depending on if we have a single, double, or triple bond. But there are fractional values as well, and we'll get into that when we talk in the next slide while talking about resonance. Bond strength, you should know, decreases or increases with increasing bond orders. So the larger your bond order, the stronger your bond is. Hopefully this makes sense because it hopefully makes sense that a double bond is stronger than a single bond, and a triple bond is stronger than both a double bond and a single bond. At the same time, one of the things that we've already talked about is that the length of your bond is actually inversely proportional to the bond order. In other words, a triple bond with a bond order of 3 is actually the shortest bond length versus a bond order of 2 or a bond order of 1, bond order of 1 having the longest bond length. Okay. So let's continue talking about bond order on the next slide. So let's talk about fractional bond orders. If a compound has resonance structures, then the bond order that we calculate is actually the average of all the bond orders in the molecule. For instance, if we look at NO3, NO3 minus has 5 plus 6 times 3 plus 1 valence electron. In other words, 24 valence electrons total. And nitrogen's our central atom. We can draw this like so. And I'm out of electrons. So yet again, I need to pick one of these oxygens and erase a lone pair and turn it into a double bond. And this is my Lewis structure for nitrogen, or nitrate, sorry. Like carbonate, we can have 3 different versions of this where we move the double bond from there to there. Could be in any one of those 3 locations. The actual bond order of any of these guys, all 3 of these guys have the same bond order because they have resonance structures that show that. We calculate it just by averaging all of them, right? This guy's a bond order of 2. This guy's a bond order of 1. This guy's a bond order of 1. Well, I have 3 bonds that I'm averaging, so 2 plus 1 divided by 3 gives me 1.3333 repeating as my bond order for all these bonds in nitrate. So that's how we calculate a fractional bond order for a structure with resonance. If I was just asking, hey, what's the bond order of this guy, this bond, then it's 2. Or this one, and it's 1. If I was asking you, hey, what's the overall bond order of every nitrogen-oxygen bond in this compound, it's 1.33333, repeating. All right, so let's make some room here for the next part of this slide. So again, just to reiterate, as bond length decreases, bond order increases. As bond order increases, bond strength increases. Just another. Okay, so we do have one more periodic table trend that we need to discuss, which is electronegativity. Electronegativity is the ability of an atom in a molecule to attract electrons to itself. This is very similar to the trend for electron affinity, and they even sound similar, but different, right? Because electron affinity is for an atom, an element by itself. In this case, we're talking about a molecule and an atom within one of the in a molecule. So electronegativity has numeric values associated with it, but generally you're not given these values. We just tend to follow the trend, which is that our electronegativity increases as we go up and to the right. on the periodic table. And we can kind of see this trend as we look at the numbers in the table, right? Fluorine being the largest number at a value of 4 for its electronegativity, and then the lowest being cesium and rubidium and potassium. One of the things that you definitely need to kind of take note of is that this trend, the increasing side to side, is way, way, way larger of an effect than up down, right? If you look at the difference, for instance, between lithium and sodium, you see that it's a 0.1 difference between their electronegativities. But then if you look at lithium versus beryllium, it's a 0.6 difference. So moving side to side is definitely going to increase your electronegativity way, way more than up down. And that's something that you kind of have to know in the back of your head when you're looking at this trend, that the side to side movement across the periodic table is going to be way, way more important than up down is. All right, so as always, if you have any questions, please shoot me an email, come to office hours. If you want to meet up one-on-one, I'm always happy to set up a Zoom meeting with you guys to help.